Hello my friends. In my last videos, I have covered the concepts of many signals. That means impulse signal, step signal, ramp signal, parabolic signal, sinusoid or sinusoidal signal, exponential signal, many signals, gates poles or rectangular poles, triangular poles, sampling function or sampling signal, sync signal, signum function. So many fundamental signals I have covered in my last videos. ओके अगर आप लोगों को समझ में नहीं आया तो फिर से वो वीडियोस आप लोग देख लीजिएगा, ठीक है। बहुत ही इंटरेस्टिंग टॉपिक्स था, बहुत ही मज़ेदार कॉन्सेप्ट्स था, तो उसको ध्यान से देख लीजिएगा, समझ में आ जाएगा सब कुछ। ओके, नाउ हम लोग जो पढ़ चुके हैं ऑलरेडी, जो वीडियोस में बना चुका हूँ, उसको एक बार समराइज कर लेते हैं, क्योंकि ये सिग्नल सिस्टम का ये जो चीज़ है, मतलब ये जो कॉन्सेप्ट्स है डिफरेंट टाइप्स ऑफ स्टैंडर्ड सिग्नल्स के बारे में, तो उसको ध्यान से देखना बहुत ज़रूरी है। अदरवाइज इट इज़ वेरी डिफिकल्ट टू अंडरस्टैंड द रेस्ट ऑफ द टॉपिक्स बेस्ड ऑन दिस सिग्नल्स एंड सिस्टम्स। ओके, तो अब कोशिश करते हैं, हम पहले समराइज करते हैं, उसके बाद हम लोग दूसरे टॉपिक्स के तरफ मूव करेंगे। तो पहले समराइज कर लेते हैं क्या क्या हम लोग पढ़ चुके हैं स्टैंडर्ड सिग्नल्स के बारे में, तो समराइज कर लेते हैं, देख लीजिएगा, ठीक है। तो हम लोग क्या पढ़ चुके हैं, तो इम्पल्स सिग्नल के बारे में हम लोग पढ़ चुके हैं। एक्चुअली एनी सिग्नल रिप्रेजेंटेड बाय एक्स इज ए फंक्शन ऑफ टाइम। तो एक्स इज dependent variable, t is independent variable. Understood? So any signal is represented in this manner. So I have already told. Now if it is continuous time signal, you have to mention within the bracket t. T is having any value from minus infinity to plus infinity. That means it's continuously. You have to take for all values. You have to consider for all values of t. Here the signal is x is a function of t. It is a continuous time signal. Anyway, this x may be voltage, may be current, may be force, may be anything else. It is a physical quantity. Similarly, this time, this is only time. You have to consider only time, because in signal system analysis we are considering the independent variable is time. So you can take any independent variable for your mathematics point of view, but here in signal systems point of view we have to consider only time as the independent variable. That means x you have to take anything. So generally in electronics and electrical engineering we have to consider this x is either voltage or current, but you can take anything as x, any physical quantity as x. That means you may take force, you may take pressure, you may take temperature, anything you can take for x. Anyway, so x is a function of time. It is the notation which is used for any type of signal. Now what are the standard signals? For standard signals you have to use standard notation. Generally standard notations are used. So del t, this is impulse, unit impulse. For unit impulse you have to mention this. For unit step you have to mention ut. For unit ramp you have to mention rt. For unit parabolic we have to mention pt. Try to understand. Similarly, for other signals, that means you can say exponential, you have to mention expt. This is for exponential signal representation or notation, which is used for exponential signal. Similarly, you can say rectangular, rect, t, rectangular signal, triangular, trit, triangular signal notations. These are the notations which are basically used. Signum function, sgnt, this is signum t, signum function. For signum function we are using this notation sgnt. Understood? For sampling function we have to use sat. This is a sampling function. For sync function sinct. These are the notations which are used for standard signals. Sin t for sinusoidal signal, cosine t for cosinusoidal signal. These are the notations which are used for standard signals, and I have already defined, I have already discussed about these standard signals in my previous videos. Understood? Now let me discuss actually one by one again, and what are the relationship among these standard signals also I have covered. Again I will repeat these things. So now quickly let us see about these standard signals. पहले हम लोग देख लेते हैं इम्पल्स फंक्शन के बारे में। दैट मीन्स इम्पल्स क्या है, डेल टी। डेल टी, व्हाट इज द डेफिनेशन? Del t is equal to infinity for t is equal to 0. It is equal to 0 for t is not equal to 0. Try to understand. So it is equal to 0 for t not equal to 0. It is equal to infinity for t is equal to 0. And integration minus infinity to infinity del t dt is equal to 1. This is very important. This last line is very important. So this complete is the definition of unit impulse. This complete is the definition of unit impulse. That means how to sketch it? So this is time axis, this is your del t, you have to mention here. So this is basically del t. Here you have to mention 1. This 1 is nothing but the area of this function. See here, minus infinity to infinity del t dt. That means area under del t. This area under del t is equal to 1. Area under del t from t minus infinity to infinity, minus infinity time to plus infinity time, area under this function del t is equal to 1. So therefore I have to mention in this manner, this 1 is nothing but actually area of this del t. Now if you consider a del t, so this is nothing but a del t is equal to infinity for t is equal to 0, is equal to 0 for t is not equal to 0. And the most important thing is integration minus infinity to infinity a del t dt is equal to a. That means इसका एरिया क्या होगा? इसका एरिया a होगा। अगर इसको प्लॉट करोगे तो इसका एरिया a है, it is a del t. When the area is a, you have to mention this is a del t. Understood? This is a del t. Now see the most important concept. When the area is 1, it is known as unit impulse. When the area is a, it is known as impulse having strength a. Impulse having strength a. See, this a is not the height. This a is not the amplitude. This a is the area. In the notation, when we are mentioning a del t, now what is a? A is the area of the impulse. Area under the curve. This is very important. Strength, इसको कभी कभी strength बोलते हैं. Impulse having strength a. So see, the most important concept, a is nothing but the area. A is the area. This is very vital. Okay. So this is about the impulse. So similarly, we can cover about the step function. Step function. See here, step function means you may first consider unit step function. Actually function means what? Here function means we are dealing with signals. Function is nothing but signals. Here in this signal system topic you can say any function is nothing but the signal. So here unit step signal, it is denoted as ut. What is the definition? Ut is equal to 1 for t greater than, see here, 0, is equal to 0 for t less than 0, is equal to half for t equal to 0. This is most important. Is equal to half for t is equal to 0. What does it mean? That means if you plot, you will find this type of plot ut. So is equal to 1 for t greater than 0. See here, 0 के बाद t greater than 0 value is 1. t less than 0, 0 से पहले कितना वैल्यू है? 0. All the values are 0. See, values are 0. Now is equal to half, t is equal to 0. Actually at t is equal to 0, this function is not defined. Because at t is equal to 0, this function having any value. This value, this value, this value, this value 1. Highest value 1, lowest value 0. So therefore, you have to take the average value at t is equal to 0. Now what is the average value? 0 plus 1 by 2. That is 1 by 2. That means it is considered that at t is equal to 0, this function having value half. So this is most important. Try to understand. At t is equal to 0, the function is not continuous. It is discontinuous. Because before 0, the value is 0. After 0, the value is 1. So therefore, at 0, this function is discontinuous. If the function is discontinuous, at the point of discontinuity, you have to take average value, and what is the average value? Average value is half. So now I have covered the unit step. This is why unit step, because height you are considering 1. Height is 1. Height अगर 1 है तो इसको unit step बोला जाता है. अगर इससे पहले मैं a लिख दूंगा a u t, देन ये जो हाइट है ये 1 नहीं रहेगा, ये क्या हो जाएगा? ये हाइट a हो जाएगा. राइट अंडरस्टैंड? ये हाइट क्या हो जाएगा? a हो जाएगा. दिस इज a u t. दिस इज a u t. दिस इज टाइम एक्सिस. दिस इज a u t. That means how to define this AUT? You can mention this AUT in this manner. AUT is equal to A for t greater than 0, is equal to 0 for t less than 0, and is equal to A by 2. That means 0 lowest value, A highest value, average value A plus 0 by 2, that means A by 2 at t is equal to 0. So this is the definition of unit step function. Understood? So now these things I have already covered in my previous videos. You just check. That means I have covered impulse, I have covered a step, unit impulse, only impulse having strength A, now step and only unit step and step. Step means AUT. इसका amplitude A है, height A है. That means step having height A or amplitude A. But when you are mentioning A del T, this is impulse having area A, strength A. This is most important. Try to understand in the notation. Though A is mentioned here just before del T, here also just before UT A is mentioned, but still the meanings are different. Here it is strength, here it is height or amplitude. Okay. Now similarly I have covered what is actually impulse function, what is a ramp function. Ramp function, how to mention this ramp function? Ramp function is a RT. RT is equal to what? T for t greater than 0 is equal to 0 for t less than 0. Here you can put actually greater than equal to, because this is continuous at t is equal to 0. If the function is continuous at t is equal to 0, you can put actually greater than equal to, there is no problem. See here. So if you plot, see here, y is equal to, if rt is a, suppose any function xt or yt, so y is equal to mx, slope is 1. So therefore it is slope 1. It is having slope 1. So now t greater than 0, 0 onwards, ये फंक्शन प्राप्त कर सकते हो. Before 0 the value 0, before 0 value 0, less than 0 value 0. So this is the plot and this is known as a unit ramp because slope is 1. See, इसका पहले क्या है? 1 है. So that means it represents the slope. It represents the slope. Try to understand. Del t before it 1, area 1. Ut before it 1, height 1. Rt before it 1, slope 1. So similarly, if I will put ART, that means you have to write A, t greater than equal to 0 is equal to 0, t less than 0. Now here the slope is A, actually this is AT, sorry, AT, because y is equal to mx, AT. That means if you plot, it is very simple, the plot is just like this, slope is A, slope equal to A, this slope is equal to A. Understood? This is your RT, this is your ART. Clear? So that means when you mention A del T, area A, AUT, height A, ART, slope A. So notation you just mark. Notation is very important. Understood? Now similarly you can say the parabolic signal, how to define parabolic signal. Parabolic signal I have already discussed. Parabolic signal is denoted as a PT. So Pt is equal to t square by 2 for t greater than equal to 0 and it is equal to 0 for t less than 0. Try to understand. So now here if you plot, this is time axis, this is parabolic t square by 2. So t square by 2, here the equation is t square by 2, 0 onwards. 0 onwards the equation is t square by 2 and 0 से पहले क्या value होगा? 0 होगा. Understood? Now if you differentiate this function, that means Pt is equal to t square by 2. Let us differentiate t greater than 0, greater than equal to 0. Now, if you differentiate dpt by dt, what you will find? This is 1 by 2 into 2t, t greater than equal to 0. Actually, we are differentiating t greater than equal to for t greater than equal to 0. So, t cancel, that is equal to t. That means, whatever the derivative function, you will find actually t. T means mx. That means, after derivative, you will find this is dpt by dt. ये जो फंक्शन है इसको एक बार डिफरेंशिएट कर लें, तो कर लेने के बाद डिफरेंशिएट करने के बाद क्या मिलेगा? ये फंक्शन मिला y इज इक्वल टू, दिस इज सपोज एक्चुअली एक फंक्शन y फंक्शन, y इज अ फंक्शन ऑफ t, दिस y इज अ फंक्शन ऑफ t इज इक्वल टू mx, mt, x means here t axis, that means slope is 1, slope equal to 1. That means when we are mentioning pt, so 1 is what? इसके पहले क्या है? 1 है. What does it mean? After derivative slope. So pt t square by 2, तो इसको अगर डिफरेंशिएट करोगे एक बार, आफ्टर डेरिवेटिव स्लोप बिकम्स एक्चुअल 1. अंडरस्टूड? सो बिफोर pt, if 1 is mentioned, that is after derivative slope, but if a is mentioned, a pt, then you have to mention a into t square by 2 for t greater than equal to 0. and is equal to 0 for t less than 0. What does it mean? It means after derivative slope is a. So if you differentiate, you will find actually the straight line whose slope is a. After derivative slope is a. Understood? So this is known as unit parabolic. This is known as parabolic after derivative slope a. This is unit parabolic because a is 1. When a is 1, that is unit parabolic. When a is a, it is after derivative slope is a. Understood? So that means about these signals, these are the fundamental signals what I have covered. Many signals I have discussed in my last few videos. These signals, which signals are known as the standard signals, and these signals having the applications, various applications in the future study of signals and systems. Okay. So now that means again I am discussing del t. Before this 1 is there, this is strength 1, this is unit impulse. Ut, this is unit step. Before this 1 is there, 1 is height. Then rt, before this 1 is there, this is a ramp, unit ramp. Pt, before this 1 is there, this is after derivative slope. So here strength is 1, area is 1, here height is 1, here slope is 1, here after derivative slope is 1. Because 1 you can mention before every notation. Now if this is a del t, this is a ut, this is a rt, this is a pt, that means how to mention after derivative. See here, after derivative. As here this is after derivative a, that means you can say this is strength a, area a, this is height a, this is slope a, this is after derivative slope a. Understood? So these are the some fundamental concepts you must have to know. Next, see rectangular function. So I have mentioned a rectangular function. How to define this rectangular function? Already I have covered. Rectangular function is generated as RECTT. Okay. So now actually this function is nothing but you can plot in this manner. This is minus a half. This is half. This is 1. This function is rectangular t. Rectangular t. Rectangular t. So that means you can say this is equal to 1 for minus half less than equal to t less than equal to half. Actually it is not equal to, but since it is continuous, actually the signal is this. But in case of continuous case, we are joining this. This is not actually available. If it is available, then this is the discontinuity. These are the discontinuity. Here actually this is one discontinuity, here other discontinuity. Signal direction can put from minus infinity to infinite. That means here you are coming, rising, going, falling, going towards infinite. Okay. So anyway, so this signal is known as a rectangular pulse and it is equal to 0 else. Matlab before this value 0, here also value 0, after this value is 0. So this function is known as a rectangular function. So if the amplitude is a, here height is 1 from minus half to half. Now if height is a, you can mention a rect t. So that is equal to a from minus half to half, and it equal to 0 else. Okay. So if the height is a, here the height is 1, the most important function. Now if after I will cover the scaling operation, but before that you just mention, in general you can mention a rect t by tau. See here, what is the width? Width is 1, minus half to half, width is 1. So now if t by tau, in the denominator tau is there, within the bracket in the denominator tau is there, this tau is nothing but actually known as width of the pulse, width of the rectangular pulse. Here it is equal to 1. See, here you can say it is 1. What does it mean? Rect t, actually you can mention rect t by 1. This 1 is width. Similarly, when t by tau, the tau becomes the width, but the pulse is surrounded, the pulse you can plot around 0, even function. So here this is the pulse minus tau by 2 to tau by 2, height is a, amplitude is a. This is the plot. That means if you consider the total width is tau. The total width is tau. Understood? That means t के नीचे जो लिखा रहता है वो टोटल विड्थ होता है पल्स का. ये नोटिस में a rectangular t by tau, a rectangular t by tau. So that means this is the general notation which you have to use for rectangular signal. That means you can say a rect t by tau. See here, very interesting. A rect t by tau, a rectangular t by tau, a rect t by tau is equal to a for minus tau by 2 to less than equal to t less than equal to tau by 2. The total width must be tau and is equal to 0 else. ये हो गया डेफिनेशन रेक्टेंगुलर पल्स का. समझ में आ रहा है कि नहीं? ओके. So this is basically the rectangular function. Similarly, you can cover about the triangular function. What is actual triangular function? Triangular function, how to denote? It is very simple. Triangular function can denote in this manner: triangular t. What is this a triangular function? Try to understand. It is very simple. How to define this a triangular function? Actually, the triangular function is just like this. Here, when triangular t means here -1 to 1, the total width is 2. But in case of rectangular function, when you are mentioning rectangular function, the total width is 1. इसका नीचे क्या है? 1 है. लेकिन इसका नीचे 1 है. ये जो 1 है, ये one side width. ये notation very important notation. That means you can say this is your triangular tree. Understood? And here, what is before this? This is your 1. 1 is the height, you can say. Maximum height is 1. So this is nothing but known as a triangular function. Very interesting. This is triangular function. Similarly, if you mention a triangular t by tau. A means actually maximum height. So here you can consider a means maximum height. This is a. Now tau is one side width. Tau minus tau. One side width is tau. But in case of rectangular function, whatever in the denominator, that is total width. But here it is considered as one side width. This is the notation you must have to remember. This is very interesting. Okay, these are the notations you must have to remember, and accordingly you just proceed for the future study in the signal system topic. Okay, good. Now see what you have to do. This is your rectangular pulse and triangular pulse. Okay. Then sinusoids, you know, sin t. So you know about this plot. If the amplitude is a, that means you have to consider this is sin t. So sin plot starting from 0. So this is your sin t. For all time you have to plot. That means what is the amplitude? Amplitude is before this what is mentioned? 1. 1 means here amplitude. And for here it is -1. So sin t varies between -1 to +1. So this is your sin function. Similarly, cos t, you know cos t at t is equal to 0 value is 1, and before this 1 is there, that means it is also from -1 to +1. It is from -1 to +1. Sorry, this is from -1 to +1. So this is your cosine signal. You know about this signal sin t, cos t. But remember, t is equal to 0, sin 0 is 0. T is equal to 0, cos 0 is 1. So it starts from 1. This is very interesting. Understood? This is your cosine signal, this is your sine signal. Now exponential signal. About exponential signal also I have covered. Exponential signal. Exponential signal means you can say expt, exponentials. It is 3 types. You can say e to the power -t. Then you can say this is for all t. Another exponential signal you can consider exponential signal. This is e to the power t. Okay, another exponential signal you can consider expt. This is e to the power minus mod t. Now if you plot, this is exponentially decay, the plot will be just like this, exponential falling signal is tarah. Time axis is here, this is your e to the power minus t. Now if you plot this signal, this is exponential rising function, this is t. Now here at origin e to the power 0, when t is equal to 0, e to the 0, 1. Here also e to the 0, 1. See here, the most important concept. So here if you plot, this is both sided. That means t mod t is t, mod t is equal to t for t greater than 0. Now t greater than 0, if you consider mod t is equal to t, then what is the function? E to the minus t. E to the minus t means this type of function. This is 1. Now when t less than 0, it is equal to minus t for t less than 0. When t less than 0, you can put here actually minus t. Minus means e to the power plus t. Minus plus. So if the plus t means rising function. T less than 0, you have to plot rising function. So this is your both sided exponent. So 3 types of exponential signal I have covered. Understood? Now if you put a here, that means this is actually scaling factor, nothing is there. Okay? Now if you take actually a value positive, then this a value if you take positive everywhere, then we will find out this. Understood? So this is nothing but these type of plots you can get for exponential signals. I have already discussed in detail in my previous videos how to sketch actually the exponential signals. Next, signum function, signum signal. Signum signal is denoted by SGNT. SGNT. It is equal to 1. So for t greater than 0. It is equal to -1 for t less than 0. And it is equal to 0 for t equal to 0. That means if you sketch, see here 1, here -1. Now at 0, what is the which value we have to take? At 0 the value is between from is from -1 to 1. So highest is 1, lowest is -1. What is the average value? 1 -1, 1 plus -1 by 2. That means 1 -1, 0 by 2, that is 0. That means we are considering at t is equal to 0 the value is 0. So this function is known as signum function. Signum t. Greater than 0 value 1, less than 0 value -1. This is your signum function. Okay. Now similarly, I have covered the sampling signal. Then what is basically the sampling signal? Also I have discussed sampling signal SAT. So this is nothing but sin t by t. This is the definition of this sampling function. Sampling function. And how to sketch this signal? I have already discussed. The signal sketch just like this. This is your sampling function. 0 value 1. So if it is A, then you have to consider A here. If it is 1, then you have to consider 1. This is your sampling signal. Similarly, sync signal, sync t. Actually, this is sin pi t by t, pi t by pi t. So difference is sampling t, sin t by t, sync t, sin pi t by pi t. That means if you put pi t here, then sampling pi t is equal to what? In place of t, you can use actually pi t, sin pi t by pi t. Here you have to put pi t. Then what will find? This is the definition of what? Sync t. Sync t. That means what is the conclusion? Sampling pi t is equal to sync t. This is very very important. Sampling pi t is equal to sync t. And what is the plot? Here it is 1. Try to understand. Here it is pi, 2 pi, minus pi, minus 2 pi. But if you sketch actually sync function, same shape plot. You will find actually same plot. But here it is 1, 2, -1, -2. It is also 1, there is no problem. So this is your sync t, this is your sampling t, This is the difference. Because sampling pi t, if you scale with respect to pi, time scaling, then automatically you will find 1, 2 here, -1, -2 here. So that scaling operation I will discuss later. Understood? So sampling t is sin t by t, sync t is sin pi t by pi t. This is very important. Try to understand. ये बहुत important concepts. ठीक है? That means exponential signal, sampling signal, sync signal, rectangular signal, triangular signal, signum function, then actually step, ramp, parabolic, impulse. About these signals I have already covered. So in my next videos I will discuss the classification of signals. That means what is energy signal, what is power signal, what is periodic signal, what is non-periodic signal, what is even signal, what is odd signal, what is inverse signal, what is invertible signal. So every classification, every type of classification, what are the classifications are there in our syllabus, we have to cover actually one by one in my next videos. तो सारे वीडियोस को देखते रहना, आराम से देखते रहना, ध्यान से समझने की कोशिश करना. ये जो वीडियो में जल्दी बोल दिया क्योंकि ये सब चीज़ मैं ऑलरेडी पढ़ा चुका हूँ. इसको कंसेप्चुअली एक एक करके धीरे धीरे आगे जो टॉपिक्स होगा धीरे धीरे एक एक टॉपिक को हम लोग कवर करते जाएंगे, सो दैट यू कैन अंडरस्टैंड इन वेरी वेल मैनर. एंड आई आफ्टर एक्सप्लेनेशन you definitely have minimum doubts in your brain, and whatever the doubts you can ask in the comment box. So I will try to answer almost all the doubts regarding the topics what I will cover in the next videos. Okay, thank you very much.